All right, so the last page of notes here for 1.1 through 1.4. And these ones here are really just the reverse of what we did on page 3 in that last video. So it says convert the equations from the previous linear system, so the ones we just did, into slope-intercept form and graph them below. So it does say specifically to change it into slope-intercept form, so make sure that we're doing that. Let's take 3, the first one here, so 3x plus 2y equals 21. And we're going to subtract 3x from each side. Leaves us with 2y equals negative 3x plus 21. And then divide by 2. Divide everything by 2. And we're left with y equals negative 3 halves x plus 21 halves, which is 10 and a half. And normally we would leave it just as an improper fraction there, but if we're graphing, we need to get an idea of kind of where to start. And so on this graph below, and so I kind of did my work in red, so this line will be the one that's in red here. And we're going to go up to 10, so 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 and a half, just a little bit above right there. That's our y-intercept, and the slope of negative 3 over 2. So down 3, 1, 2, 3 over 2. Down 3, 1, 2, 3 over 2. Down 3 over 2. Down 3 over 2. And down 3 over 2. All right, and so let's kind of sketch that line out. Here we are. And now the other line was 4x. And 4x minus 3y is equal to 11. So I'm just taking this one here and bringing it out over here. So 4x minus 3y is equal to 11, and this time we'll subtract 4x. Subtract 4x from each side, and that leaves us with negative 3y equals negative 4x plus 11. Divide each side by negative 3, and that gets us to y is equal to 4/3, positive 4/3 times x minus 11/3, and that's going to be negative 3 and 2/3, just to kind of get a rough idea of where we're going to start at. So down 1, 2, 3 and 2/3, so 1, 2, 3 and 2/3. And again, this is why solving by graphing is a little bit tougher to use, because graphing 2/3 can be a little difficult. So we're going to go up. What was it? Up 4. 1, 2, 3, 4 over 3. Up 4 and over 3. Up 4 over 3. Also down 4 and left 3. Down 1, 2, 3, 4, left 3. And then we're going to go off the graph. So here's that sketch of it, and we're looking for their point of intersection, and looks like this is the point of intersection right here. And what's that point? So 1, 2, 3, 4, 5, up 1, 2, 3, and since my graph, I just did the best I could, but there weren't lattice points. Lattice points are right where the two lines, my line's even a little bit off there, right where the two lines meet. So there weren't lattice points we were even using. But as far as we can tell, that's 5, 3. And if we remember from our last problem, actually, the solution was 5, 3. So it says find the points of intersection, 5, 3. And so we got that there. Now let's head back up, and we'll do this one as well. And it does say to change it into slope-intercept form, but this might actually be good practice to, this is close to standard form. And it's not standard form because our a value here is -2, but this can be a good chance to use finding our intercepts and graphing from just the intercepts themselves. So you have an x-intercept where y is 0, And if I plug 0 into y, this whole term goes away, because 0 times negative 6 is 0, and so I end up with negative 2x equals 24, and so x would be negative 12. There's there's my x-intercept. My y-intercept would be where x is 0, so 0, comma, and if x was 0, this whole term would disappear, or would give me 0 when it multiplied 0 times negative 2, and then we'd have negative 6y equals 24, and so y would be negative 4. And so with those two intercepts, so 0, negative 4, 1, 2, 3, 4. Was that one supposed to be in red? Yeah, negative 4, and then negative 12. That's going to be off our graph a little bit. So 10, 11, 12, somewhere right around there. We can see that the line's going to be going somewhere through there. But since it did go off, let's actually go ahead and follow the directions. But just as a reminder, here's how you can graph by finding your intercepts. So even if you don't know the slope, you can still graph from standard form. All right, but let's actually we'll follow the directions. So negative 2x minus 6y equals 24. Add 2x to each side, and that gives us negative 6y equals 2x plus 24. Divide everything by negative 6, and we get y is equal to, so divided by negative 6, and negative 6. Y is equal to negative 1/3 times x minus 4. All right, so that's the y-intercept we thought. And so negative 1/3, that means we're going to go down 1 over 3, down 1 over 3, down 1 over 3. And that, hey look, that's right on track of what we thought we would be getting when we graphed by the intercepts. And so, all right, well done us. Graph that line. There it is, just a little sketch of it. And the other one, we'll bring that out to the side over here, was x equals 3y plus 6, and again that's this equation right here. X equals 3y plus 6, and I'll get my y on the right hand side this time since y is already over there. So subtract 6 from each side, and we have x minus 6 equals 3y. Divide everything by 3, and we end up with y. So I'm going to put it back on the left hand side now. Y equals 1/3 x, because the coefficient here is 1. So 1 divided by 3 is 1/3 x minus 2. And so now we've got to graph that line. So go to a y-intercept of negative 2, and up 1 over 3, up 1 over 3, up 1 over 3, and down 1, left 3. There's our intersection right there, down 1 over 3, down 1 over 3. If you recall from the previous problem, our solution was at negative 3, negative 3, just as our point of intersection is right now, negative 3, negative 3. So we found our points of intersection. And so it says, what conclusion can you draw about the solution to a linear system, like a system of equations, and the point of intersection of the graphs that of the equations of that system? And so the solution to a linear system, and actually it's not even going to be just a linear system, but the solution to a system of equations in general, though right now we are dealing with just linear, but this is going to be an unneeded addition to our definition here. But the solution to a system of equations is the point. And when we get later on to nonlinear, then we'll have the points. Is the point, or the points where the graphs of the equations intersect. of the equations intersect. So, and again, that's the point of intersection. The point of intersection. That is going to be the solution to the system. All right, point of intersection is the solution to the system. So just as a reminder, and kind of putting that all back together, we've got, you can solve by substitution, you can solve by elimination, or as we just showed, you can solve by graphing. All right, hope that helped.